Hello everyone, welcome to 99% in 99 days. Today is 37th day in our Diksha Vedantu Foundation YouTube channel, and today we are going to discuss electricity, circuits and Ohm's law. So let's start with the chapter breakup. So we will break this into two parts. First of all, in the part where we are going to discuss about electricity, here we will discuss electric current and circuits. Then we will discuss electric potential and potential difference. We will also discuss briefly about circuit diagrams and Ohm's law, the most important concept, Ohm's law. From Ohm's law, there is one more concept that is that is resistance, but that we will discuss in tomorrow's lecture. So what all will be covering there in the resistance chapter, resistance part, will be covering factors on which resistance of a conductor depends, then resistance of a system of resistors, then resistors in series, resistors in parallel, then we will also discuss heating effect of electric current, and we will discuss electric power. So this everything we will discuss tomorrow, and here everything we will discuss today. So today's lecture will be slightly shorter, tomorrow's lecture will be slightly longer, right? So if you are thinking, okay, I don't have time, you can check this lecture quickly as quickly as possible, because this is going to be very, very helpful for you. Now let's start with electric current and circuit. So what is electric current? Electric current is the amount of charge flowing through a particular area in unit time. So basically electric current is the amount of charge. What is the meaning of amount of charge? Suppose we have a circuit, okay, any circuit we have, we will see the diagram, and through that circuit, if the charge flowing through the conductor in unit time is Q, okay, so say in time T, Q amount of charge is flowing. Charge is generally represented by the symbol Q. So then what is electric current? Current is basically Q divided by T. This is the basic definition of electric current. Okay, so rate of flow of electric charges. We say the rate of flow of distance, rate of flow of change in distance, right? That is the rate of flow, anything rate, generally for example velocity. Velocity is rate of flow of distance, rate of change of distance. Right, rate of change of velocity is acceleration. So rate of change means time rate. Okay, if you divide by time, then we call it rate of change, right? Now circuits. Now let's look into the fact what is circuits. A continuous and closed path of an electric current is called an electric circuit or closed circuit. So basically when we are saying electric current has to flow through something, right? So it has to flow through a conductor. Now if I say it has to flow through a conductor, not all conductor can carry electricity unless and until it is closed. So if it is closed like a loop, okay, that loop can be as big as you can imagine, but if the loop is closed, then only the current can flow. For example, the current that is flowing coming from the power supply station, it is being produced say 200 kilometers far away from you, where there is a dam, there the electricity is produced and then it is transferred to your home. Right, so electricity is not being produced in your city or anywhere. So from there it is being transferred to you, and then you are consuming it, and then you are sending the electricity back to the place where it is produced. There are different way to do that, but for simplicity you can imagine that this is a long way of a circuit. But if somehow the power supply line which is carrying the current to your home got disconnected, maybe because of some accident, maybe due to some fault in the line, maybe due to a storm or whatever it is, okay, if that line get disconnected, then there is no electricity in your home. So you say that your parents or your some friends will say that there is a load shedding or there is a power cut. Right, so load shedding is slightly different issue. Power cut is a very common thing where somehow the circuit is disconnected and you are not getting that power to your home, the electricity to your home. Okay, electric power we will discuss in tomorrow, but for now you should remember that if the circuit got disconnected, then you will not get the current, you will not get the electricity to your home. So when you are receiving the current, that means circuit is closed. Okay, if you switch off the light, if you switch off the light, basically what you are doing, you are disconnecting the circuit yourself. If you switch off the AC, if you switch off the TV, if you switch off the fan, what you are doing, you are basically manually doing the disconnection. You are manually creating something which is called open circuit. So if the circuit is broken anywhere, the circuit is said to be a open circuit. So if the circuit is broken, now if you switch off the light, basically what you are doing, you are removing the connection. You are inside the switch, there is a mechanism, through that you are basically breaking the circuit, and by breaking the circuit you are making this a open circuit. So current cannot flow through the light anymore, and the light is turned off. Similarly, when you are switching on the light, you are converting an open circuit into a closed circuit. Okay, now let's see, this is the simplest example of a electric circuit. As you can see, there is a key is basically the switch. Okay, there is a key and the current is flowing through this bulb. This is a symbol of a bulb, very weird symbol, but this is because in the past we used to use tungsten wire for our bulbs, so that's how the symbol is designed, and it is still used, because even though we have switched on from tungsten filament bulbs to LEDs, most of the places we use filament bulb, LED bulbs only, but still this is the symbol. Okay, so this is the symbol of the bulb. Current is flowing through this bulb and it is passing through. There is a device which is measuring the current. We will talk about that in a while, and it is reaching here. Okay, now let's see. The SI unit of electric charge is coulomb. Okay, which is equivalent to the charge contained nearly 6 times 10 to the power of 18 electrons. This is very, very important for your MCQ questions. Okay, you have to remember this value, 6 into 10 to the power of 18. Okay, this is the nearly these many electrons is equals to 1 coulomb. 1 coulomb is a huge unit, the big unit. We will discuss about it in more detail in our next class 11th. If you are from CBSE or AP1, if you go to any state board. Okay, there we will be discussing about this coulomb charge, quantization, etc. A lot of difficult things, but for now you should remember that the unit of charge is coulomb, and we know that the electron possesses a negative charge of 1.6 times 10 to the power of minus 19 coulomb. So 1 coulomb is basically 6 times 10 to the power of 18 electrons. Now what next? The electric current is expressed by a unit called ampere, and an ampere is basically 1 coulomb divided by 1 second, and the device that is used to measure the current is an ammeter. Okay, ammeter is the device which is used to measure the current. Okay, ampere is the unit, ammeter is the device to measure current. So this is also very, very important for your objective questions. And if you are also very confused, like your answering objective questions, that what to do in my future and what should I do, whether I should study for science, whether I should go for commerce, or what section I should study. If I study in class 11th, do I study blindly, or I have to have some focus in my career? So if you are confused, worry not. Diksha presents DSAT, okay, Diksha Scholastic Aptitude Test. Here you will get a 1 hour lecture, and after the lecture, whatever doubt you might have on the lecture, that doubt clarification session. Then there will be an aptitude test based on that lecture, and based on the result that you have got in the exam, there will be a one-on-one counseling for you exclusively to tell you that if you focus on say JEE in future, you will score a very good result, or maybe you are not super good in JEE, but you can focus on NEET exam, or you are not maybe if you prepare for KSET, you will score a very good result and you can secure top rank in the Karnataka engineering colleges. So based on your career choices and based on the results, okay, the counselor will guide you for your best future options. So don't wait, fill up this form, and it is happening every Sunday in our Diksha campuses offline exam. This is nothing nothing to do online, everything is offline. So worry not, just fill up the form. Our representative will guide you for more detailed information. Right? Now let's continue with the electric potential and potential difference. The electrons move only if there is a difference of electric pressure called potential difference along the conductor. Okay, so electrons will generally, for example, if I say that there is a conductor, this conductor already has a lot of electrons. Okay, but this electrons cannot move on its own. Okay, for example, if I have a glass of water, can the water inside the glass can move on its own? Water can move, water can flow, but can it move on its own? By default, it cannot move on its own. You have to have something called a potential difference, okay, along the conductor. If you can apply a potential difference, then these electrons will flow. So how can we apply potential difference? We will see that in a while. The example I gave you. So I have water normally placed in the ground, it will not flow on its own. If you take the water, if you take it to certain height and if you bend it, then that water will flow. Why? Because you have created this height difference. Now as you have created the height difference, the water can flow from top to bottom. So basically this height difference for water is same as potential difference for electrons. Okay, so electrons can flow only if there is a potential difference. We define the electric potential difference between 2 points is an electric circuit carrying some current as the work done to move a unit charge from one point to other. So I guess you have not learned in detail about work done, but just for the sake of definition, you have to remember that the potential difference is defined as the work done to take one charge from one point to another. For example, I gave you one example. I gave you one example that I used the water from ground level to some height. So to take the water from ground level to that height, I have to do some work, right? Now I have given that work into that water. That water now has some potential energy. So that potential energy, if I bend it, that potential energy is now converted into useful work. Okay, so some work we do, some work the system does, and that's how we get the useful work. We have to convert it. Okay, so here the work done to move one charge from one point to another, whatever work that we are doing, that work is basically called the potential. Okay, so point from one point to other, that is the definition. Work done, very important term. Okay, you will learn about work done again. As I said, you will learn more about work done in your class 11th. The potential difference V between 2 points is given by work done divided by charge Q. Now you cannot take one positive charge always. Okay, whatever charge you have, that charge you have to take. So to uniform it, what you have to do, you have to divide by the charge, the amount of charge that you have taken, so that the charge by default becomes 1. Okay, so if you take exactly 1 coulomb charge, then it's fine. Whatever work you are doing, that work is potential. But instead of taking 1 coulomb charge, what if you are taking 110 coulomb charge? Okay, or maybe 1 nano coulomb charge? Then how much work, what is the potential difference? So in that case, you cannot simply measure the work done and convert it into potential. So in that case, you have to divide it by the amount of charge that you have moved. So be careful. Now the SI unit of electric potential difference is volt. Okay, 1 volt is equal to 1 joule per coulomb. Joule is the unit of work done. Okay, coulomb is the unit of charge. So 1 volt is basically 1 joule per coulomb. The potential difference is measured by means of an instrument called the voltmeter. The voltmeter is always connected in parallel across the points between which the potential difference is to be measured. Okay, so potential difference is always connected in parallel. So if you want to measure the potential difference, suppose this is the some conductor, and if you want to measure the potential difference, so this is called parallel combination. This is called parallel combination. This is the battery, this is the key. Okay, this is say ammeter, So this is called parallel combination, and this is called series combination. We will discuss about that more in our next class, combination of resistors. So there we will see what is the meaning of parallel, what is the meaning of series. But here you should remember that if they are connected like this, hanging, okay, if they are connected like hanging, then this is a series parallel connection. But if they are connected along the circuit, then it is called a series combination. Okay, now let's look into the circuit diagrams, few symbols that you have to remember. Okay, this is an electric cell. Electric cell is represented by single one large line, one smaller line. Large line represents the positive end of the cell, and the small line represents the negative end of the cell. Okay, a battery or combination of cell is represented like this. Sometimes this is also represented like this. Okay, instead of this showing this internal lining, they are omitted and they are just drawn like this. So all the positives, these are the positive lines, these are the negative lines. So how many number of positive? The same number of negatives will be there, and if it is starting from positive, the end should be at negative. This is also a symbol of battery. Okay, so if you see some symbols like this, don't get afraid, they are also the same as this. So basically here multiple cells are connected in series. So for example, if you are using a TV remote, okay, your TV remote might be requiring two cells, two AAA cells. Or if you are playing with, if you are a kid and if you are playing with remote control car, your control card may be requiring 4 or 5 batteries or 6 batteries depending upon the quality of the remote control car, right? I hope many of you have played remote using that car. So if you are using that, there are multiple cells. So one unit is called cell. When you apply more than one, then they are called battery. Okay, the entire combination of them are called battery. Okay, next is plug, key or switch. Okay, this is the symbol for plug, key or switch. Okay, this is open switch, that means you have switched off. This is basically means that off position, off position. Okay, if you switch off, then this is the position, this is the symbol. Okay, so in the past there was no such rocking switch. Okay, these switches are called rocking switch. There used to be symbol simply knob. Okay, it will be plugged in and the circuit will be completed. So those kind of switch used to be there in the past, that's why the symbol is like that. So basically you have taken out the knob. Okay, if you put the knob in, then knob is inside, so this is an on position. This is the closed switch. Okay, closed switch. This is also switch, this is also switch, this is closed switch, that is the on position, this is the open position or off position. Okay, open or off are the same thing. Next is wire joint. Wire joint means so for example, you have seen the wirings in your home. Okay, most of the times it is concealed inside, but sometimes it is visible and you might see that from one end the wire is coming and then it is going to another direction. Suddenly in between there is another side line which is going to a third direction. So this is called that. This is the symbol for that. This is a wire joint where multiple wires are being connected to a single line. Okay, cross wire, basically this means even though the lines are going across, they are not connected, they are excluded from each other. So basically if this is the line, this is the line, they are not connected, they have a gap in between. But if they are connected together, then this is the symbol. So if they are connected, suppose this is the line, this is the line, and they are connected, then this is the symbol for they are connected. And if they are not connected, then you have to draw it like this. Okay, this is the way to show that they are not connected. Okay, now next is electric bulb. Obviously you cannot draw this diagram, so this is the symbol for electric bulb. This is the symbol for electric resistance, about which we will study more in our next class. Variable resistance or rheostat. Rheostat is a device which can be used to control the resistance. For example, if you are using a switch to control the speed of the fan, which is a type of rheostat. Okay, not the exact rheostat, but you can consider that to be a variable resistance type of rheostat. Okay, so basically that is a rheostat. Now ammeter, this is the symbol for ammeter, this is the symbol for voltmeter. Same, only for ammeter A is written, for voltmeter V is written. Okay, this is used to measure current and this is used to measure voltage. Now Ohm's law, the most important concept from this chapter. So it's the statement of Ohm's law, state and explain Ohm's law, state the Ohm's law is very, very important. Let's see. If the temperature and other physical conditions remain unchanged, then the potential difference V across the ends of a given conductor in an electric circuit is directly proportional to the current I flowing through it. Okay, so very, very interesting thing. Okay, we will discuss in a while. So first let's see. If you have a circuit, you have a circuit, say one resistor only. I am showing only the resistor, rest of the circuit is already there. Okay, and in suppose the potential difference, potential here is VA, potential here is VB, and some current is flowing here, I. Now what is the potential difference? Potential difference V is basically high potential minus low potential. Current always flows from higher potential to lower potential. So potential difference is VA minus VB. Okay, now what is Ohm's law? Ohm's law states that current in a circuit is potential difference across the ends of a given conductor is in an electric circuit is directly proportional to the current. So this is proportional to the current flowing through it. So V proportional to I. Okay, sometimes you might say I is proportional to V, that is also okay. V is proportional to I, that is also okay. So if you, what is the meaning of proportionality? Proportionality, I hope you have learned that if X is proportional to Y, that means they have a direct relationship. You can remove this proportionality symbol using a equal sign. Only thing that you have to do is you have to multiply a constant. You have to multiply a constant to write this equal sign. So basically they have a relationship and there is a constant factor in between them, then they are called proportional. So here in this case V can be written as V equals to R times I. Okay, or sometimes we write this V is equal to IR. This R is the constant of proportionality, and if two quantities are proportional to each other, for example X is proportional to Y, then if you plot the graph, okay, here we have we have done V versus I graph. In this V versus I graph, as you can see, as we are changing I, the voltage is increasing, current is increasing, voltage will also increase, and it will not increase randomly, it will increase such that the line is a straight line. Okay, this is a straight line graph. This is a linear graph. The graph, if the two quantities are proportional, their graph is called linear graph. So if you see a graph like this, then you can definitely see these two quantities are directly proportional to each other. Okay, and in some cases you might find that graph is drawn from like this. In some variables they are also proportional, but there is also a constant factor, constant involved in this. You will learn about that in your maths class, but they are also proportional. You should remember that they are also proportional. So this is the symbol, this is the nature. When two quantities are proportional, their graph should be a straight line graph, right? Now this quantity that we have introduced as a constant of proportionality is called resistance. Okay, this resistance, about this entire thing about the resistance, we will discuss in our tomorrow's lecture. Now there are some limitations of Ohm's law. What are the limitations? Limitation is that if the temperature changes, Ohm's law is no longer valid. Okay, if physical state changes, so in physical state means suppose as you are passing the electricity, okay, the conductor melted because of the electricity, or the conductor becomes something else. Okay, maybe it vaporizes, or its physical state is no longer the same as it started. So physical state means means solid, liquid, gas, plasma. There are other states as well, but if the state changes, then definitely Ohm's law is not valid. Okay, there are few conductors, few non-ohmic conductors. For them you cannot apply Ohm's law. One of the example is semiconductors. There are other examples of semiconductor as well. There are other examples of non-ohmic conductors as well. So for them you cannot apply Ohm's law. So these limitations are also very important, okay, and very often asked in your exam. Okay, and if you are also someone who is confused about your future, what to do in your future, what should be your focus, just to study science, or while studying science you should focus more about more upcoming future, that what I have to do, what should be my goal is. If you have a fixed goal, your career is very, very settled. So for that, Diksha is presenting Diksha Scholastic Aptitude Test, DSAT, and it is happening across Diksha campuses every Sunday. Here you will get a 1 hour lecture, and once the lecture is over, there will be one aptitude test. Based on the aptitude test results, there will be one-on-one counseling for you, and that counselor will tell you what should be best choice for you, whether you should focus on JEE, you should focus for NEET, or you should focus for KCET in future. So everything is available in our Diksha campuses every Sunday, and for that you have to fill up this form. The link is given in the description, and if you like this video, don't forget to give it a thumbs up and share it with your friends. I'll be back with resistance tomorrow. Till then, bye.